All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 5.4 in Algebra 2, which is completing the square. So what is completing the square? Well, it's a method of writing any quadratic expression as a perfect square plus a constant. So perfect square meaning sort of like what we saw with that perfect square trinomial in the last video. So when I say perfect square, I mean something like, for example, I could write x squared plus 6x plus 13 as x plus 3 quantity squared plus a 4. So what I mean is taking any quadratic expression like this one, x squared plus 6x plus 13, and writing it as a perfect square, right, plus some constant, right? So perfect square here and a constant there, right? And the constant doesn't have to be a square. I just happened to write that it was 4, so it's a square. So why, right? So this way, when we write a quadratic, we can write it in what's called vertex form, which we're going to talk about later in this particular section. And that's useful for graphing. Later on in calculus, this is a skill that sometimes you're going to need when you are asked to integrate a rational expression. The trick is that it's a skill that you're going to be that you'll need, but you won't be expressly asked for, which is what happens a lot when we move forward in math, is that we learn these skills and we're not, right now I might say complete the square and that's the whole problem, but when you get to calculus, I'm never going to say that. You're just going to have to spot, oh, this is a problem where I can use that algebra skill I learned a year ago or 2 years ago. So let's go ahead and move forward to how we complete the square. So we're going to walk through a sample because what I've found with these steps is they make an awful lot more sense if I show you them with a sample problem. So we're going to complete the square on 2x squared minus 12x plus 25. Now this is actually a pretty hard problem because it has a number in front of x squared. It has a coefficient that's not 1. But we're going to go ahead and walk through that. So here are the steps. Step 1, ignore the constant. It's not that this 25 is gone, but I'm going to write this 25 awkwardly far away. I'm going to be like, hey, 25, you're in timeout. It's cool. You're still here, but you're all the way over here. The next thing I'm going to do is I'm going to factor out whatever the coefficient of x squared is, which in this case is a 2. Sometimes that's going to factor out of this next term easily, and sometimes it's not. In this case, it's going to factor out nicely, so this isn't a completely horrible problem. And in my parentheses, I'm going to leave this awkward amount of space. Notice I didn't forget that the 25 exists. I'm just leaving it over here in timeout by itself, right? Now I'm going to do the thing that I call the triangle step, which actually has 3 parts. I'm going to take this linear expression, okay, right here, and actually I'm just going to underline it. I'm going to divide this thing by 2. It's always 2. It's not 2 because there's a 2 here. It just happens to, it's just a 2, okay? I divide by 2, and I'm going to keep the sign because it's not a 6. It's a negative 6, and that matters. So I divide it by 2, right? And I'm going to circle that number because it's important for later. And then I'm going to square that number. That's the next step, and this is why I call the triangle step, and put that number right here. So that's a positive 9, right? Because I'm adding 9. That's what negative 3 squared is. The last thing, so that was the second thing I did, and then the last part of this triangle step is I need to balance the expression. You can't just add a number to an expression without it changing its value, right? So notice ignoring the 25 didn't change the value of this expression. Factoring out the 2 didn't change the value of this expression, but suddenly I added this number and it does. But I didn't really add 9. What I added was 2 times 9. I actually added 18. So out here, I'm going to write a minus 18 because that's my balancing the expression. So just to write what I get after I do this whole step, I'm going to end up with something that looks like this. X squared, so a 2 in front of an x squared minus 6x plus 9 in the parentheses. And then out here I have a plus 25 and a minus 18, okay? My last steps, oh, and I kind of run out of room down here, my bad, okay? So my last steps, I'm going to factor the thing in parentheses. It's not an accident that this is a perfect square trinomial and it factors into x minus 3, which is why I told you this circled number would be important. So this is an x minus 3 squared, and then out here I'm going to simplify the 25 minus 18 as a 7, and I've now completed the square. All right, so what I've done essentially is write this as a trinomial that is a perfect square, and yeah, there's a 2 in front also, plus this 7, okay? So that's how we complete the square. We're going to walk through a bunch of practice problems at this, and this is the big skill for this section, okay? So moving on, let's do a complete the square. So the first step is to ignore the constant. When I show you an example, I don't usually show you the easiest version of this sample because then ignore the constant wouldn't make any sense if I didn't have a constant. So when people get to a problem like this in the homework, sometimes they're thrown because they're like, but what constant? If it makes you feel better, you can call the constant a +0, but there is no constant, so there's nothing to ignore. If it makes you feel better to be like, hey, there is a constant, it's a +0, great, go for it, it's cool. Then I'm going to factor out the number in front of x squared. Well, there is no number in front of x squared. So yet again, you're going to kind of feel awkward about that and be like, oh, I guess there's a 1 because that's the only number there is to factor out. So I do my triangle step. I divide this by 2. Remember, it's always divide by 2. I don't mean to circle it. Hang on. Divide by 2. And I get a +5. That's the number that's going to matter. I'm going to circle it, and then I square it, right? So I'm adding 25. Well, what I did right here was add 1 times 25. So out here, I'm going to subtract 25 because if I add 25, I also have to subtract 25 to keep the value the same. So now I can factor this entire expression in parentheses into an x plus 5 quantity squared, and out here I get a -25. And this is my problem with the square completed. Again, what makes this problem a little confusing is that there isn't a number in front of the a to factor out, and there is no constant, right? So it's arguably easy enough that it makes it more difficult. All right, let's try P1. You can pause me if you don't want me to do it. So again, if it helps you, you can realize that the constant is a 0, and you can realize that this is technically a 1 in front, if that helps. Technically, you're factoring out a 1, but we don't usually write it. Right, so I'm going to do my triangle step, which is divide this guy by 2, right? I get a -2, and then I'm going to square it, which is a +4. Well, that means that I added 4 to the expression, so out here I have to subtract 4. So I'm going to get that this is an x minus 2 quantity squared because I've created a perfect square trinomial. That's why it's called complete the square. I've made it a perfect square, minus 4. And that's my square completed. So let's just keep doing problems as they get progressively more difficult. Okay, so this one's not harder because of the constant. It's harder because when you go to divide this term by 2, you're going to get a fraction, and nobody likes a fraction. So again, my constant is technically 0 if that makes you feel better. You also are technically factoring out a 1 if that makes you feel better, but you could write it without the 1. So now when I do my triangle step, this is where things get a little bit dicey. This is going to be a -5/2. It's a fraction. There's nothing I can do about it. And when I square it, I'm going to get +25/4. That means that I just added a 25/4, so out here I'm going to subtract 25/4, and my answer is going to end up x minus 5/2 quantity squared minus this 25/4, right? So again, the only reason that's a step up in terms of difficulty is that people hate fractions. All right, moving on. Same idea. Again, pause me if you want to do it without me. If you need this +0, that's fine. If you need to call that a 1, it's fine. Again, it's okay to not write that 1. So when I do my triangle step, I divide this by 2 and get a +3/2, right? Keep the sign, it's important. I square it and realize that I'm adding 9/4. So out here, since that's a 1 times 9/4, I would subtract the 9/4. And my answer is going to be an x plus 3/2 quantity squared minus a 9/4. All right, moving on. Now it's going to be a little more difficult because we now have a constant to ignore. So I'm going to start by ignoring that constant, right? So there's my +5. I'm going to factor the number out in front of the x squared, but in this case, that's just a 1 anyway, so it doesn't really do much for me. And then I do my triangle step, right? Divide by 2, it's always 2, to get a -1, and then square it, so I'm adding 1. That means that I just added 1, because 1 times 1 would be adding 1. So I subtract 1 outside to balance my expression, and I end up with an x minus 1 quantity squared plus a 4. If you want to write a 1 in front of here, you can, right? But most people don't. All right, try P3. You can pause me if you want. I'm going to go ahead and walk through it. So I'm going to ignore that constant. I'm going to take out the number in front of the x squared. Again, if you don't want to write the 1 because it's a 1, that's understandable. And then I'm going to do my triangle step, right? I divide by 2, which is going to be a +4, and then I square it, which is going to be a +16. That means that I just added 16, so out here I subtract 16 to keep the value the same. It's sort of like making change out of your wallet, right? If somebody hands you a $5 bill and asks you to break it into ones, you hand them 5 ones back, because if you don't, they're going to be all sorts of mad, right? So again, you put $16 in, you take $16 out. So I get an x plus 4. This plus 4 is coming from that circled number, quantity squared, minus a 1, and that's my answer.